Welcome all. This is Aniket Vazarkar, Data Science and Business Analytics interns at the Spark Foundation. Let's begin with the task one, that is prediction using supervised machine learning. We'll begin with importing all the necessary libraries required for this Jupyter notebook. We'll basically importing pandas, numpy and matplotlib. Pandas for data analysis, numpy for basic mathematical operations, and matplotlib for data visualization. Moving forward, reading the data from the remote link. This is the link on which the data has been located. The data set looks like this. This is the data set on which we'll be working. It has got two entities, that is us and the scores. So moving forward, as now the data has been loaded into s.data, it's time to visualize the data. So we will be displaying the data here in the notebook. We'll be using the data variable .head, and it displays the data set. Moving forward, the data variable .describe, so s underscore data .describe is it basically describes the two entities of the data, that is us and score, in up to greater extent. Moving forward to data.shape, it gives the shape of the data, that is the structure of the data set, that it consists of 25 rows and 2 columns respectively. Moving forward to the data info, s underscore data.info, it shows that it shows the concise information about the data frame, the constraints, the data types, and pretty much more than that. Now moving forward to one of the most important part, that is the data visualization. We'll be using the scatter plot for the same, so we can easily find out the theme of the data set. So let's move forward towards plotting the graph. So s underscore data, that is the variable in which the data is being stored, dot plot, and using the two entities of the data set, that is us and the scores. So after that the data plot, after that the graph shows like this. On x-axis we have kept the R studied, and whereas on the y-axis we have kept the percentage scores. So from this graph we can clearly see that there is a positive linear relation between the numbers of R studied and the percentage of the score. Mathematically saying that number of R studied is maybe proportional or directly proportional to the percentage score. We'll take a look in the evaluation of the model data. So moving towards the preparation of the data, it is the next step to divide data into two parts, that is attributes and labels, inputs and outputs precisely saying. So the data has been divided into two parts, x and y respectively, as you see. So now that as we have our attributes and the labels, the next step is to split the data into training and testing sets. We will do this by using the scikit-learn's built-in library, that is a train test split method. So after applying the train test split, I have split the data into two parts. That is for the training purpose, I have given 80% of the data set, and 20% of the data set is kept for testing purpose. Moving forward towards the training of the algorithm, one of the most important part. So now we have split our data into training and testing sets, and now it's finally the time to train our algorithm. Now we are using the linear regression algorithm for the training purpose. As you can see, linear regression is there. So now after this training model, one must print the dummy message. I have printed here model rendered successfully. So if there is any kind of error, you must be notified about it. Moving forward towards plotting the regression line. Here we have plotted the regression line. It shows the relationship between the scores obtained to the R studied. So it basically shows the linear regression versus the trained model. Moving forward towards making the prediction. Now as we have trained our program, or we can say that we have trained our algorithm, it's time to make some predictions. So using the x underscore test and y underscore prediction, we are making some kind of predictions. So these are some of the predicted values which we'll be using, and moving forward we will be compare this predicted values towards the actual values in the data set. So to compare the values, we are using the df is equals to pd.data frame actual y test predicted y predict. So this is the actual data set values, whereas these are the predicted values. See, there are some sort of difference between them. We can call this as some margin error. We'll discuss later. So the main part comes into play now. The question, that is predict the score if a student studies for 9.25 hours a day, what would be its percentage? So we'll predict this using the model we have trained above. So we have inputted the value here, that is 9.25. And using the linear regression model, we have predicted the scores here. So the score says that if a person is studying for 9.25, this is the predicted score predicted by our ML model. Moving forward towards the evaluation of the model, so we have to evaluate the model. So this is the final step. Evaluation basically means the performance of the algorithm. So this step is particularly important to compare how well different algorithms perform on the particular data set. For sake of simplicity, we have chosen the mean square error. There are many such type of metrics. So using the mean square error, that is mean absolute error, we came to know that there is the error margin of 4.183859, approximately 4.2 in the prediction to the absolute value. We can see that here. So the actual value is 20, whereas the predicted value is 16.8. That is approximately 4. Here 27, here 33. So that's the mean square error. And moving forward towards the conclusion, if a student studies for 9.25 hours a day, then the predicted score is almost equal to 93.691732 as predicted by our linear model. Thank you.